Hi everyone, we're going to be taking a look at this next lesson on statistical reasoning. As you know, we've been working our way through Unit 6, Chapter 5, where we're looking at statistics and looking at various tools that we use to interpret data and to make some meaning out of the data that we have. Today we're going to be starting a section which involves something we call standard deviation. Now, the purpose of what we're doing is to help you understand what standard deviation is, how you find it, both manually and with a calculator, and then how you use it to help you interpret the data that you're looking at. A couple of words, vocabulary words that I want you to be watching for. Make sure that you watch for understanding what the word deviation means, and then standard deviation. Those are two words that we'll be using a lot in our conversation and text with one another about the data that we're looking at. So please be on the lookout for those words. So as we begin, first of all, I wanted to double check to see if you understood what the word to deviate actually means. So if I were to use it in the context of I plan on making some New Year's resolutions this January, and my hope is that I will not deviate from those New Year's resolutions. Hopefully that helps you understand a little bit what we mean by the word deviate. Deviate means to go away from or stray away from something. So the question really is, how does that have anything to do with mathematics and in particular statistics? So let me ask you another question then. As we have been looking at the data that we have in front of us up to this point, we've tended to focus on what part of the data. So if you think of mode, median, mean, range, well, range clearly showed us all of the data and wanted to know how far the data is stretched from one end to the other. But all of the other three had what we called a central tendency. They were looking at the middle of the data. The mean was literally the average of the data, so somewhere in the middle of the pile. The median was literally the middle. And the mode, especially in data that's not, just made up, but data that's actually looking at something in particular, usually comes in around the most commonly used or expressed data, so the middle again. So if we had a line plot like this one and we were kind of analyzing the data that we've been given, we tend to focus on this part of the data and just say, okay, where's the middle? And what does this mean to us? Well, in some situations, it's useful to examine how data has deviated from the mean, which literally means how far away is it from the average. And that's where standard deviation comes in. A measure of the dispersion or the scatter of data values in relationship to that mean or average in the middle is called standard deviation. A low standard deviation means that most of the data values that you have in a set are close to the mean. And a high standard deviation means that most of the data values are further away from the mean. So they're spread out away from the average. So what we're going to do is check to see how we actually calculate this value mathematically, and then we'll try to explore what it tells us. So we're going to take a look at it in the context of a question. So we're looking at a question which involves basketball, a basketball game. The coach of a varsity girls basketball team keeps statistics on all of the players. Near the end of one game, the score is tied, and the best starting guard has fouled out. The coach needs to make a substitution. So the coach examines the stats for 5 guards who are on the bench in the last 10 games. And here are those stats. So you will remember when we were working on this in class that I gave you a worksheet that we were going to be able to use. And so if you don't have that, make sure you come and ask for it and I can give it to you. But the first question I asked you to do was to look at this data set, and see if you could make a call on which players seem to be the most consistent in their results. And so as we look at this, most people took some time and realized that when they zoned in on it, the page seemed to be quite consistent. Her highest was 35, her lowest was 33, and all of her numbers kind of seemed to bounce in around there. So we say that she's most consistent. What we're going to do is take this data set and now look at it through another lens from a new perspective. And so we're going to take a look at what it means to find the standard deviation, and then we'll play around with that number a little bit. So as you get used to the math that's involved in this, you're going to need to remember and recall the symbol that you already know. You learned that the mean of data was expressed by writing it as X with a line over top of it, that this stands for mean. So let's take a look at the table, and what we're going to do is use these numbers and create the standard deviation. So the first thing you did was take all of her data that she had for page and write it in this column. And I asked you to take some time and figure out what the mean of all these data points actually was. So we find a mean by adding all the numbers up and then dividing by the total number of numbers. And we end up with a value of 33.9. Now, the second step for this was to find the deviation of the data. And what that means is you take each data point, 34 in this instance, and you subtract the mean from it. So 34 minus 33.9. So we get 0.1. And 35 minus 33.9, and we get 1.1. And 33 minus 33.9, we get negative 0.9. So we did that for all the values down the column, finding the deviation, we call it, of each row. That's the second step. We're looking at how far away is each data point from the average. Okay, and then we take those values and we square them. So this one, 0.1 squared, which would be 0.01, or 1.1 squared, which is 1.21. And then negative 0.9 squared is 0.81. And we did it for every single one of those values and found these numbers. Notice that all of them are positive because even when you square a negative, it turns into a positive. Okay, the next step that we have is to take all of these values, which are the squares of the deviation, and we're going to find the mean of these values. So we add them all up and divide by the number of numbers, and we get the mean of all the squares, which turns out to be 0.69. And then to finish off, to actually find the standard deviation, we calculate the square root of this mean. And so the square root of 0.69 is 0.831. And that is what we call the standard deviation. Now, if we look at this number, what we're seeing is a number that is quite small. It's very close to 1. And what that's telling us is that Paige's numbers do not go far away from her mean, which of course we noticed as well when we looked at the data set. But now we also need to take a look at this and take a look at it from the perspective of all the other data values. And so I want to teach you how to do it with the calculator. Now, the calculator part, I might actually not stop this video to actually go over that. What I'll do is put it separately and perhaps try to find some links as well to people who are doing it for you on a video, because I do not have the ability to do that in this video. So I'll put it as a separate one. If you don't remember how to use the calculator, just pause the video and use the other resources that I put in Google Classroom for you. And then we'll carry on with this one, assuming that you know how to find it with the calculator. So the next step I'd asked you to do was to take all of these data values and find actually the range, the standard deviation, and the mean for each one of the 5 players. And when you do, you find the following values. Now I'm wondering, you know what? I think that this one was meant to be an 18, and I did not change that in this one. So bear with me. This one is for Anna is meant to be a range of 18. That was a typo on my part. And so I would need to fix it. And I think this one might have actually been a 0.831. At any rate, those mistakes are not going to necessarily affect what we're doing in this video. But what we want to do is look at this data set and begin to ask some questions. Which player has the greatest percentage range and which one has the least? And how do their standard deviations compare? So let's take a look at the data and what it implies. The one that has the greatest range is Morgan, and her standard deviation also happens to be the highest of all the others. So the highest range had the highest standard deviation. And the lowest was Paige. She has a range of 2, and her standard deviation is definitely the smallest. So there seems to be some correlation between the range and the standard deviation. When you have the highest range, you've got the highest standard deviation. So compare the means and standard deviation of the data sets for all the players and which player had the lowest standard deviation, but more importantly, what does this imply? So remember, we've already talked about this. Paige has the lowest standard deviation, and what this implies is that all of the numbers which were for her are very close to her mean. They didn't go very far away from it. And then if I look at the player that had the highest standard deviation and what it implies, which was Morgan, her data values went all out of whack. Like they went a long ways away from the mean. Some were really higher and some were lower. And so her standard deviation was high, saying that all of her data values were a long ways away from her mean. So based on the past performance, which player has the potential to shoot most poorly and which one has the potential to shoot most successfully? Well, I suppose you could say Morgan. Morgan could do a really good job and she could do a really poor job. And then again, if I want someone that I'm going to be able to rely on who's consistent, well, Paige is pretty consistent. So the last question, of course, was if you were the coach, which player would you substitute into the game? And the whole point of this is to use the data values and try and justify what you've done. Well, people looked at it and they kind of, had opinions in all different directions. And of course, if you're going to support what you are seeing by the math, you might say someone who's more of a risk taker might say, you know what, Morgan, while Morgan is, a little less consistent, she might come through and she might actually give us that, boost of the points that we need. Others said that Patrice was a good option. She's got a pretty strong mean and she's got a pretty good standard deviation. She doesn't go too far from that. So she's pretty consistent and she's quite a bit higher than Paige, who was very consistent. So there were lots of different opinions that you could have, but remember the whole purpose of it is to back up what you're saying with the math that you see in front of you. So let me take a look at a few more symbols. And I think actually what I might do is stop here and do a part 2 of this recording because I can tell it's going to get very long. So I'll pick it up. You'll be able to pick up the part 2 in a second here. So stay tuned for more later.